Hello everyone, welcome to Unit 1, Lesson 1. Today what we're going to talk about this thing called the function. Our goals are to understand the basic premise of a function, understand the difference between an input and an output, and calculate an calculate an output given an input for a function. We'll see what all of that means as we go through the lesson. But those are our goals. Those are the things we want to make sure we know how to do. Now, before we get into functions, there is a bit of review that we need to do, and I need you guys to remember your order of operations, right? So this is how we determine which order to do several calculations in. So the acronym that has probably been used in the past for you guys to help you remember the order is PEMDAS, right? So parentheses, exponents, multiplication, division, addition, and subtraction. So when we see a problem like this here, number one, we see a lot of different operations. We see addition, we see multiplication, we see division, and the order of operations tells us what order to do those things in. All right, so let's do an example real quick so we can see how PEMDAS works. So notice here I have a division and I also have a multiplication. I don't see any parentheses, I don't see any exponents, but I have multiplication and division. And these two, even though it goes 3 and then 4, they're kind of ranked the same. So you want to work left to right as you do multiplication and division. So I'm going to do this 24 divided by 8 first, and then I'm going to do this 5 times 3 next. So the 3 here at the beginning stays right where it's at. And then I'm going to do this 24 divided by 8. So 24 divided by 8 is 3. And then I'm going to do this 5 times 3. So notice I still have a plus sign there. So I'm going to carry that down. And then I'm going to do this 5 times 3, which is 15. Okay, and then I've taken care of the multiplication and the division, so now I can focus on addition. So I can do 3 plus 3, which is 6. And then I will have 6 plus 15, and if I do 6 plus 15, I'll get 21. So the correct answer here would be 21. And that's just using that order of operations. All right, at this point, the video is going to stop. It's going to ask you to try one of these problems on your own. So good luck. As soon as you're done with that problem, go back to the video. All right, let's do number 2. So number 2 is a little bit different. It's got some parentheses. It's got some addition. So I'm just looking at the different things from PEMDAS here, and I see parentheses, I see addition. So let's see how this works out. I'm going to start with the first thing, which is parentheses. And inside of the parentheses here, I see a 6 plus 2. So I'm going to do that first. So I still have 8 plus, here's this 1, and then inside of this parentheses, 6 plus 2 is 8, right? So it turns into something that looks like this. Now I look at the expression, I notice that there is a multiplication here between the 1 and the 8, so I'm going to do that first. 1 times 8 is 8, so I just get 8 plus 8, and then I'm going to do the addition. So 8 plus 8 is 16. So my final product here will be 16. All right, video is going to stop again. Ask you to try one of these on your own. All right, so now that we know order of operations, we can talk about a function. All right, there are many technical definitions of what a function is, but for today, the only thing I really need you to understand is what a function does. All right, and what a function does is it takes a number and it does stuff to it, right? So if I gave you a 3, I'm going to do stuff to that 3, and once I'm done doing stuff to it, I'll have a new number. That is what we call the output, all right? So that number that we start with, right? So if you can imagine it's like a machine, I'm going to give you a number to start with, we're going to do stuff to it, and we're going to get something out, all right? So when we look at this thing here, I gave you the graphic of a machine just to kind of help you think about how it works. But let's talk about the different parts here. You'll notice this f of x thing that's going on here, and this actually tells us the name of the function. So this f that we see here, that is the name of the function. So the name of the function is f. All right. The rule is what we're going to do to the number. All right. So this 2x plus 4 is our rule. It tells us how to calculate things. The input is right here inside of the parentheses. Okay, so our input is whatever x is. The output is actually this whole thing on the left side of the equal sign. So the output is actually f of x, right? So whatever we get out after we do the rule is going to be what f of x is. And just remember, I know it looks weird, but this is not f times x. This is f of x. That's what that says. All right, now we're going to give it a try so you can see what I'm talking about here. All right, so we're going to do this, right? So notice the name of the function is f. Where the x was, they put a 2. So they're telling me that the input is a 2. So I'm going to come over here to my machine. I'm going to put a 2 into the machine, which means the x is going to get replaced with a 2. So I'm going to come over here and write my rule. 2, but instead of an x, I'm going to put a 2. So it's not going to be 2x. It's going to be 2 times 2 plus 4. And then I use my order of operations to evaluate this rule. So 2 times 2 is 4. And 4 plus 4 is 8. Right? So my output is 8. When I put a 2 in, I did stuff to it, I got out an 8. Okay, I'm going to try it again. This time we're going to input a -2. Right? So the -2 goes into the machine. It's going to replace x. So I'm going to get 2 times -2 plus 4. Right? And then I use my order of operations again. So 2 times -2 is -4. And -4 plus 4 equals 0. All right, so in this case, I put a -2 in. I got a 0 out. All right, one more time. This time, I'm going to put a 0 in. Right, so I'm going to come over here. Instead of putting a -2 into my machine, I'm going to put a 0. And let's see what that looks like. So my rule becomes 2 times 0 plus 4. All right, so I got 2 times 0 plus 4, order of operations. I start here with the multiplication. So 2 times 0 is 0, and I still have plus 4, and 0 plus 4 equals 4. All right, so my input was a 0, my output was a 4. All right, guys, again, video is going to stop. It's going to ask you to try one of these on your own, see how you do. All right, now let's try a few that may be a bit more challenging. It's got some more stuff going on here. You'll notice we got rid of the machine for these problems, so really all we need is the rule, and we need to be given an input or an output. So when I look here at number 1, I can see the rule right here. The name of the function is still f, and my input is the variable x, whatever they tell me x is going to be. All right, so when I look down here, it says find f of 2. All right, so that means I'm taking this 2, that's my input, it's going to go in here for x. So I'm going to rewrite my rule with that replacement. So I'm going to say 3, and then instead of an x, I'm putting in a 2, so I have 2 plus 1 minus 4. And then I use my order of operations to evaluate this thing. So I've got 2 plus 1 inside of the parentheses, so that's going to leave me with a 3 times 3 minus 4, and then 3 times 3 is 9 minus 4, and then 9 minus 4 is 5. Right, so if I'm thinking about those previous problems, right, my input was a 2. Oh man, that's horrible. Try that again. Right, so input was a 2, output 5. Right, I put a 2 in, I got out a 5 after I did all the calculations. All right, let's try it again for number 2 here. So this one's got a squaring thing going on in there. All right, so let's see if we can handle that. Notice the name of my function has changed. It's no longer f, it's g. And notice that the input has also changed. It's no longer x, it's n. But nothing is going to change. The name of the function really doesn't matter. The variable that we use doesn't matter. It's the same thing as f of x. It's just now g of n. All right, so sometimes mathematicians use different letters at different times for many different reasons. So let's give this a try. It tells us that we are going to find g of -4. All right, so n is going to become -4. So I'm going to be plugging that in right here. Okay, so I've got -4 squared, and this is important. Make sure you put this in parentheses when you go to your calculator. All right, and then we still have plus 1. All right, so that n got replaced with -4. It's going to be squared, and then we're going to add 1. All right, and let me show you what's going on with the calculator here. And I'll show you why it's important that we put a set of parentheses around that. Calculator will turn on. There we go. Alright, so I'm just going to start by doing -4 without any parentheses to the second power. Alright, so that's my power button right there, so I can hit 2 and then whatever power I want. And when I hit enter, I get a -16. But that would be incorrect, okay? So you want to make sure you put a parenthesis around that, so you'll see -4 in parentheses like that, and then we'll go to the second power, and watch what happens here. Notice that I get a +16, and that's simply because if I do -4 squared, okay, -4 times -4 is what you're supposed to do, and a negative times a negative always gets you a positive. So this should be a +16 plus 1, and then 16 plus 1 is 17. Okay, so that means I put a -4 in, I got a +17 out. Alright, last one here. We've got a function, its name is t, its input is the variable x, and they are telling me to put a 5 in for the x. No problem. So I've got equals square root, I'm putting a 5 in there for the x, plus 4. Alright, so then 5 plus 4 is 9. So inside of that square root, that's a square root symbol there, we're going to end up with a 9. And if you remember how a square root works, what we're looking for is a number that I can multiply by itself to get a 9. And that number is 3, because 3 times 3 is 9. Alright guys, that's it for this lesson. The video is going to stop again. It's going to ask you to practice one more problem. Make sure you get that done. If you have any questions, come on back to the Zoom meeting. You can ask me any questions you have in person. Otherwise, move on to the daily discussion and start working on that. Have a great day.